Hello. So in this video, we're going to be computing another limit, but in this case, the limit, as we will see, is going to be at a point that is not continuous for the expression. So we're going to have to do a little more work. Okay. So we have this limit, right, as x approaches 2 of this whole big fraction mess. So typically a good place to start when you're sort of confronted with any kind of limit of any kind, like any situation with a limit. A good place to start is to plug in the value and see what happens. To be clear, this won't usually give you the actual answer. That'll only work when it's a continuous function. But what we're really looking at is sort of what goes wrong will tell you what to do to sort of how to proceed to get the actual limit. Okay. So the first thing I'm going to do is take this sort of expression bit. I'm not going to claim the limit equals it. I'm just going to rewrite the expressions. Note, I'm not going to have an equal sign here. But what I'm going to do is plug in that x equals 2 part. So I'm going to have 2 squared minus 5 times 2 plus 6 all over 2 squared minus 9 times 2 plus 14. So again, all I'm doing here is plugging in 2, but note I'm not claiming that the limit equals it, right? I'm just going to compute and see what happens. The assumption being that something will go wrong, because, you know, it always does. But how it goes wrong will tell me what I'm going to need to do from there. Okay, so then this thing is in fact equal, so I can write equals. And that's going to give me 4 minus 10 plus 6 over 4 minus 18 plus 14. And putting all this together, right, I'm going to have 4 and 6 is 10, minus 10 is 0. And 4 and 14 is 18, minus 18, also 0. That makes me sad. So again, not surprising, things went wrong. But again, how it goes wrong tells me a lot. So here, the fact that I'm dividing by 0 means that I don't know what this thing is. It's undefined at that point. It's a domain restriction. So definitely not continuous. But the fact that it's 0 over 0 and was originally, you know, up here, this thing was originally a polynomial when I plugged it in. The fact that it's 0 over 0 tells me that what I really want to try to do now is take my original expression, right, my original polynomial divided by polynomial, this whole thing here, and factor that in an attempt to simplify the fraction, okay? Because essentially what's happening is if I get 0 over 0, that means there's some common factor that is causing a 0, and I want to try to see if I can cancel that out, okay? So I'm going to take my original one. I'm just going to rewrite it so that I have it here. X squared minus 5x plus 6 divided by x squared minus 9x plus 14. About half of all errors are transcription errors, so it's always a good idea to double check and be like, okay, I wrote the x squared, it is minus 5x, it is plus 6, minus 9, plus 14, all set. And now I want to factor this to simplify it. I'm not going to go into detail about that, but there are resources if you don't remember how to factor polynomials. So here I'm going to do a coefficient method on the top. So 2 things that multiply to 6, add to negative 5. So that's x minus 2, x minus 3. And in the bottom, multiply to 14, add to negative 9. So that's going to be x minus 2 and x minus 7. Now, remember, our original bit, right, is this limit as x goes to 2. But if I have x going to 2, that's a 0, right? I have a root of x minus 2 in both of these. So that's where that 0 in the top and bottom is coming from. So that means that this thing, from a limit standpoint, right, because limits don't care about the value at the point, just near it. And everywhere near x equals 2, this factor, right, is not 0. And that means that in the top and bottom, it's some number that's the same, meaning we can cancel this. So to be very sort of clear about the math notation, I could not write that this equals the thing with it being, canceling out, right? If I wrote this, where I'm canceling, again, to be clear, if I'm looking at canceling these terms, and I wrote this equals x minus 3 over x minus 7, this is not quite true, right? Because I have it claiming these are equal, but these are not quite equal. They're equal everywhere where x isn't 2, because at 2, this thing is undefined, but at 2, this thing is, right? So this would be true for everywhere that x is not 2, okay? But if I'm taking the limit as x goes to 2, which is what's happening, right? Then I don't care what's happening at x equals 2, because that's the whole thing with limits. They don't care what's happening at the point just nearby. And so that means that if I'm looking at this as a limit standpoint, right? If I look at this as the limit as x goes to 2 of x squared minus 5x plus 6 over x squared minus 9x plus 14, then the limit is indeed equal to the limit of this thing. So as x approaches 2 of x minus 3, x minus 7. And again, this is honestly equal. I don't have to worry about for x not equals 2, because the limit that's built into the limit, right? Part of the limit is that we don't care if x equals 2 or not. We're ignoring the point x equals 2. So the limit, all the points nearby x equals 2 here, are all the same points for x being nearby but not equal to 2 here. And here, this thing is nice and continuous at this point. So that means that I can plug in x equals 2 here. 2 minus 3 over 2 minus 7, where now I don't want to write limit because I'm actually evaluating, right? So as soon as I have the plugged in thing for the limit, I no longer should have limit there. And this thing is just -1 over -5, or just 1/5. Okay. So again, as a quick sort of recap, I'm presented with this big block of a limit. I'm not sure what's going on here. So the first thing I do, which is pretty much always the first step for any limit of any kind, is plug in and see what happens. Not that I have a lot of hope that I'm just going to get a nice answer, because it would have to be continuous at that point, and sadly, math class, we never make it that easy, right? So it's almost certainly going to go wrong, but how it goes wrong is key. So I plug through, I get the 0 over 0. Sure enough, things went wrong, but that tells me that the next sort of step, the thing that I do to solve the limit overall, is to factor and simplify. So that's how I got this x minus 3 over x minus 7. And once I figure what that is, that means that, again, I canceled the x minus 2, but that's where I'm taking the limit, right? X going to 2. So that means that I can take the limit of the original thing is the limit of this simplified thing. Now I can plug in. Everything works. Okay. So in this video, we're going to be computing another limit, but here we're going to be computing the limit of a piecewise function. So typically when you're doing a piecewise function, almost always the limit is going to be targeting an x value that's one of these sort of transition points from one function type to the other, right? So when we look at what we're asking, right, so this limit as x goes to 2 of this function, we want to find where 2 is in the domain, and sure enough, right, we have 2 here and here. So it's a point where we're transitioning, right, from this first function, if we're to the left of 2, and then going to the second function when we're to the right of 2. So when we have this transition point, then that means that we need to tackle limits with that sort of very basic definition, meaning looking at the right and left limits and seeing if they both exist, and if they both exist, are they equal, and all of that. So that's where we're going to start. So I'm going to start by looking at, right, so I want the overall limit as x goes to 2 of g of x, but I'm going to start by looking at the limit as x goes to 2 from the right, let's say. I can do right or left. It doesn't matter which one you do first, so I'm just doing the right of g of x. So what this means then is that I need to find what g of x equals when I am to the right, meaning slightly more positive or slightly bigger than 2. So if I look right here, it's looking at slightly smaller or just to the left of 2. Here is the just to the right of 2. You might also notice, right, that the 2 is not included in either one, but that doesn't matter, right? So limits don't care what it equals at that value or if it's even defined at that value. So the fact that it's not defined at 2, I don't care. But, so I'm looking at the limit as x goes to 2 from the right. So that means that I want this second function, this middle function, because that's what g of x equals when it's slightly, right, when x is slightly bigger than that 2. So this is going to be the limit as x approaches 2 from the right of what g of x is, which is that, right, this middle function, this x minus 5. So at this point, I can basically just pretend I don't care. Like I can just pretend g of x isn't even a thing. All I care about is now this thing, right? This expression. I can forget the fact that it came from a g of x, the fact that g of x is this whole big sort of mess of a piecewise function. I just want this. But x minus 5 is a line. It's a polynomial, right? It's continuous everywhere, which means that the limit as x approaches 2 from the right, well, it's a continuous function. I can just plug in that value to get what it equals, right? So this is honestly equal to plugging into, right? This is 2 from the right as opposed to positive 2. So plugging into 2 minus 5, and that's just negative 3. Okay. So that was doing 2 from the right. So now I'm going to take, so maybe mark this off. That's one task. Now I'm going to look at the limit as x approaches 2 from the left of g of x. Right? And so this is approaching 2 from the left, so I want something slightly smaller. So if I look right here, right, this is where the x is smaller than 2. So that means that g of x, limit, as x approaches 2 from the left, g of x is really this first function, this minus 2x plus 1. Okay. So here, again, I can sort of forget that it's from a g of x. I'm just looking at this thing. This thing is another line. It's a type of polynomial. It's continuous at that point. So that means I can just plug in 2, right? I can plug in where I'm going. So this is negative 2 times, and again, remember this is 2 from the left, not negative 2. So this is just plugging in 2 plus 1. So this is negative 2 times 2 is negative 4 plus 1, which is negative 3. Okay. Now, last but not least, I want to look at these two values, right? So I look at the limit as x goes to 2 from the right of g of x, which I've already computed. This was negative 3. I look at the limit as x goes to 2 from the left of g of x. This was also negative 3. So in order to tell if the limit exists, right, I want to check and see, and indeed, these are equal. So since the limit as x goes to 2 from the right of g of x equals the limit as x approaches 2 from the left of g of x, which, to be clear, both of these things equal negative 3, I know, right, so since this is true, then the overall limit as x approaches 2, not from the left or right, but actually approaches 2 of g of x, is exactly that thing, negative 3. Okay. So again, we were sort of starting out with this big piecewise function that we wanted to compute a limit for. And to do that, so the first thing we did is sort of found where that 2 was, but we saw sort of as usually is the case, that it's at this sort of transition point between two different functions, right? So that means that we had to break it up into the x going to 2 from the right and x going to 2 from the left. We found what the functions were, right? From the right, it was just this x minus 5, right? Because we were in that middle line. From the left, we were at the first line, the minus 2x plus 1. So we found what they were, and then we solved, which, because they were continuous, was relatively straightforward. We got minus 3 for both of them, which turned out to be really important because that's how we tell if the actual function exists, right? If we get the same value, they both existed, we got the same value, that tells us that that's what the actual full-on regular limit as x approaches 2, not from the right or left, but the full limit as x approaches 2 of g of x is that value because they agreed, okay? So that is that.